Hey guys, and welcome to our first notes video of this week. So today we're going to be doing Unit 9, Notes 3-1, Finding Excluded Values. So first of all, let's talk about rational expressions. That's what all of Unit 9 is really leading up to. So rational expression is an algebraic function whose numerator and denominator are polynomials, meaning they have a squared term, or they're factored. A polynomial is things that have more than one term. So instead of just having 4/5, we might have something that's like 2x plus 1 over 3x plus 2. That would be a rational expression because there's a polynomial on the top and the bottom. Now, with rational expressions comes a thing called excluded values. An excluded value is any value that's going to make the denominator 0. Okay, because if you think about it, we talk about a lot in math how the denominator cannot be equal to 0. We can't have 0 on the bottom. So because of that, we have to find these excluded values. So we're saying, hey, these are going to make the bottom 0. So I'm just going to say they're excluded. They don't count because they're going to make my bottom 0. So let's take a look at how some of that's going to work. So let's take a look at numbers 1 and 2. So all we're doing today is working on finding the excluded value. So it's really not that complicated. All you're going to do is you're going to take the bottom and set it equal to 0. And then you're going to solve that equation. So for this one, add 6 to both sides, and I get that m is equal to 6. Now when we're writing excluded value, I sometimes just abbreviate it EV. So the excluded value is that m is equal to 6. So that's really all we're doing for this. Taking a look at number 2, setting the excluded value equal to 0. X plus 2 is equal to 0. Subtract 2 from both sides. And x is equal to negative 2, so I'm just going to state that my excluded value is that x cannot be negative 2, and I forgot that on this one. So when we put that little dash through it, that's saying it's not equal to that. It cannot be equal to that. All right, so that's exactly what I'm saying there. Let's take a look at 3 and 4. So these ones are a little bit different because we just have a monomial. It's really going to be the same thing though. What we're going to do is we're going to take that bottom and set it equal to 0. So I have 4x is equal to 0. Divide both sides by 4. Well, 0 divided by anything is just going to be 0. So I'm stating that my excluded value is that x cannot be 0. Okay, x cannot be 0. I'm going to go ahead and I'm going to have you guys try number 4 on your own. See if you can find that excluded value. Oops. Next, let's take a look at number 5. If I can here. Extending the page. Okay, so now for this one, we're going to, again, set our denominator equal to 0. So we're going to have 3x minus 6 is equal to 0. So now this is a multi-step equation. So I'm going to add 6 to both sides. That's going to give me 3x is equal to 6. Then I'm going to divide both sides by 3. And I get that x is equal to 2. Okay, so x is equal to 2. So I don't want to say x is equal to 2. That's not what I'm trying to find. I need to state that the excluded value is that x cannot be 2. Okay, so the excluded value is that x cannot be 2. We don't want to say that x is equal to 2. We solve the equation to get that x is equal to 2, and then we need to state that our excluded value is equal to 2. So I'm going to go ahead and have you guys try number 6 on your own. All right, so state the excluded value for each expression. So now some things are factored for us. So thinking back to when you would see something like this in factored form. Well, first of all, as always, we're going to set that denominator equal to 0. So I'm saying x minus 4 times x minus 9 is going to be equal to 0. Now, you've probably seen something like this before. You have when we've factored and set up the x. Okay, so think back to what you had to do in order to get those equations. Well, you had to use the zero product property. Now remember, the zero product property says that if you have A times B set equal to 0, then either A equals 0 or B equals 0. So we're going to use that idea right here. We're going to take x minus 4 and set it equal to 0, and we're going to take x minus 9 and set it equal to 0. So now I'm going to solve each of those factors. For x, so I get that x is equal to 4, and I'm going to add 9 to both sides on this one, and I get that x is equal to 9. So now I want to write out that my excluded values are that x cannot be 4 or 9. So I'm writing out that it can't be either. Okay, I'm going to go ahead. Why don't you guys try number 8 here on your own? All right, so set each of those equal to 0. Okay, next. take a look at this one. So this one, again, it's going to be a lot of the same thing. So if you're feeling like you understand it, you can go ahead and try and do some of them on your own without the video. If you want to do it along with the video, that's great too. So what we're going to do now is we're going to take, and I'm going to take 3x minus 12 and 4x plus 12, and I'm going to set it equal to 0. All right, so I'm going to take each of those factors and set them equal to 0. And now I'm going to solve each of those for x. So starting here, I'm going to add 12 to both sides. Remember, when you're solving equations, you're doing the opposite of whatever the operation is. If it's minus, you plus. If it's multiply, you divide, and so forth. So here that 3 is being multiplied by the x. Divide both sides by 3. And I get that x is equal to 4. So here I want to subtract 12 from both sides. And then I get 4x is equal to a negative 12. Divide both sides by 4, and I get that x is equal to negative 3. Now remember, I don't want to leave it as x is equal to 4 and x is equal to negative 3. I want to state that my excluded values are that x cannot be 4 or negative 3. And that's my final answer. So I'm just stating out those excluded values. Let's take a look at number 10 together as well. I'm just going to erase some of this work so we have some space. All right, so for number 10, again, we want to set each of those factors equal to 0. So we have 3x minus 9, 6x plus 18, and we're setting that equal to 0. So I have 3x minus 9 equals 0 using that zero product property, and 6x plus 18 is equal to 0. In general, the more work you show up, the better. So that way if you make a mistake on a quiz or something, I can see where you're at. So we're going to go ahead and add 9 to both sides. And we get that 3x is equal to 9, and we're going to divide both sides by 3, and we get that x is equal to 3. Next thing, we want to do that with same with the other one, so we're going to subtract 18 from both sides, and I get that 6x is equal to a negative 18. Divide both sides by 6, and that gives me that x is equal to a negative 3. So again, I want to write out and state what my excluded values are. My excluded values are that x cannot be 3 or negative 3, because both of those would make the denominator 0. If you don't believe me, go ahead and plug it in yourself. See if it works. Okay, let's go ahead and try number 11. Bring this guy on down here. Come on. All right, so for number 11, we're going to go ahead and we're going to set each of those factors equal to 0. So I have 3x minus 12 times 4x plus 12, and we're going to set both of those factors equal to 0. So we're going to say 3x minus 12 is equal to 0, and 4x plus 12 is equal to 0. So here, add 12 to both sides, and you get that 3x is equal to 12. Divide both sides by 3, and you get that x is equal to 4. Here, subtract 12 by both sides. You want to do that first before you divide. Then you get 4x is equal to a negative 12. Divide both sides by 4, and you get that x is equal to a negative 3. So my excluded values for each of those are that x cannot be 4 or negative 3. Okay, so again, we don't want x to be equal to those because then we will have a negative in the denominator. I'm going to go ahead and have you guys try number 11, or I'm sorry, that was number 9. I just did it again. Well, congratulations. You got to see it again. So hopefully you skipped ahead in the video a little bit. Let's take a look at number 11. Let's just do it on a separate sheet of paper. So we're going to take a look at number 11. So number 11 is 2x minus 3 over 4x minus 2 times 3x minus 1. So now we're going to set both of those factors equal to 0. So 4x minus 2 is equal to 0. 3x minus 1 is equal to 0. Now we're going to go ahead and solve each of these equations for x. So here I'm going to divide both sides by 2. Well, when I do that, I get 2/4. Now we want nice reduced fractions. We can divide both of those by 2, so that's going to be 1/2. Here I'm going to add 1 to both sides, and then I get 3x is equal to 1. Divide both sides by 3, and you get that x is equal to 1/3. So we need to state our excluded values. So our excluded values are that x cannot be 1/2 or 1/3. So we put the strikeout through the equals to because we don't want them to be either. Now I want you guys to do number 12 on your own. Let's take a look at number 13. It looks kind of complicated, but it's actually not. So let's write this out. So we have 3x plus 2, 4x minus 2, 5x minus 1. So now we're going to take, and I'm actually going to set each of those equal to 0. So 3x plus 2 is equal to 0, 4x minus 2 is equal to 0, 5x minus 1 is equal to 0. So let's go ahead and solve out some of these equations. So we're going to subtract 2 from both sides, and then we get 3x is equal to negative 2, divide both sides by 3, and we get that x is equal to a negative 2/3. Here, we're going to add 2 to both sides. 4x is equal to 2, divide both sides by 4, and then we get x is equal to 2 over 4, and then that's the same as 1/2. So again, we haven't really done anything different. Even though there's 3 on the bottom, we're still setting each one equal to 0. Last but not least, let's solve this one. So we get 5x is equal to 1, divide by 5, and you get that x is equal to 1/5. Last but not least, we want to write out our excluded values. So our excluded values, oops, that was 1/5, are that x cannot be negative 2/3, 1/2, or 1/5. And that right there is your final answer. I want you guys to do number 14 on your own and then bring your note sheet up to me and I will hand out your homework. Thanks for listening.